Good morning, one and all. Welcome to session 8. This is Dr. Dana. This is session 8 on modern software engineering. We have been looking into how agile development methodologies work. We have been doing with incremental requirement gathering, customer test-driven approach, refactoring, and incremental design. And we have also looked into how to identify spots for refactoring and how to explore on the code using spike solutions, and we have also been trying to optimize our performance. Now once the performance is done, now is the software ready for deployment is our next question. Now once the development process is done and part of the testing is done using the done completion criteria, the next thought we will have, or the next session that we will do, is on exploratory testing. Exploratory testing is trying to do a lot of testing by exploring the code. This helps us discover surprises and untested conditions. As in the agile development, as we do not have any independent group of people responsible or assessing and ensure the quality of the final release, we have to do a lot of exploratory testing, which means one particularly effective way of finding surprises, gaps, and holes in our existing production code is using exploratory testing. It's a style of testing in which you learn about the software while simultaneously designing and executing tests. This is by using feedback from previous tests to inform the next. And exploratory testing enables us to discover emergent behavior, unexpected side effects of the code, or holes in the implementation. Thus, in the automated test coverage, the risks related to quality attributes that cross story boundaries, such as security, performance, and reliability, are not covered in the automated test. So we try to cover these using exploratory testing methodologies. It's a perfect complement to XP's raft of automated testing techniques. Now, exploratory testing is similar to the test-driven development and incremental design approach. Rather than designing a huge suite of tests upfront, we try to design a single test in our head and then execute it against the software and see what happens to the software and how it reacts to it. The result of each of these tests lead to the design of the next test. This allows us to pursue directions that we wouldn't have anticipated if we had attempted to design all the tests up in front. Each test is a little experiment that investigates the capabilities and limitations of the emerging production code. Exploratory testing can be done manually or with the assistance of automation tools. These works best when the software is ready to be explored, that is, when the stories of all modules are done. Now there are four major tools for exploratory testing. The first one being charters, the next observation, the third one is note taking, and the fourth one is heuristics. In this session we will be looking at these four tools and how they operate and how they help us explore our production code. Exploratory tools, the first one being charters, is nothing but a guideline for exploring our production code. Before beginning an exploratory session, a tester should have some idea of what to explore in the system and what kinds of things to look for. This charter helps keep the session focused. An exploratory session typically lasts for 1 to 2 hours. The charter for a given exploratory session might come from just a completed story. To generate charters, we work with the team to understand what information would be the most useful to move the project forward. Charters are the testing equivalent of a story. So for every story we are going to have a charter, and it gives us what to test, and it's more like a guide stating what to be tested and what is important to be noted during the exploratory test. The second major tool for exploratory testing is observation. These automated tests only verify the behavior that the programmers write them to verify. But humans are capable of noticing subtle clues that suggest all that is not right. So these exploratory testers are continuously alert for anything out of the ordinary. Such observations lead to exploratory tests to ask more questions, run more tests, and explore in new directions about the production code in hand. The third tool on exploratory testing is note taking. While exploring, it's easy for us to forget all that we have been and where we were doing and what we have tested. To avoid that, exploratory testers keep a notepad beside them as they explore, and they periodically take notes on the actions they take. You can also use screen recorders such as Camtasia to keep track of what you do. Be especially careful to keep notes about anything that deserves further investigation. If you cannot follow a path of testing in the current session, you might have to remember to explore that area more in a detailed way in the next exploratory session. So, keeping a note of all that has happened and how your production code has reacted to your exploratory tests is a must during exploratory testing sessions. And the final and the most important tool in exploratory testing is heuristics. Remember that exploratory testing involves simultaneously designing and executing tests. Some test design techniques are well known, such as boundary testing. A heuristic is nothing but an educated guess. So you can also call it as a guide, and it's a technique that aids in your explorations. Boundary testing is an example of a great heuristic. Experienced testers use a variety of heuristics gleaned from an understanding of how software systems work, as well as from experience and intuition about what causes software to break. You can improve your exploratory efforts by creating and maintaining a catalog of heuristics that are worth remembering when exploring your software. Now, some of the heuristics will be specific to your domain. For example, if you work with a networking software, you must inevitably work with IP addresses. So you probably test your software to see how it handles invalid IP addresses such as 999.999.999, which is a invalid IP address, or special IP address such as 127.0.0.1 or IPv6 format style addresses too. Others are applicable to nearly any software project that you work on. Now, these are some of the heuristics which are continuously being used in exploratory testing. The first one is none, some, and all principle. For example, if your users have permissions, try creating users with no permissions and some users with some permissions and one user with all permissions, and try checking how your production code works with all three user capacities. And the second principle that we can use is the Goldilocks principle, which confines to too big, too small, and just right. So these are more like boundary tests on a numeric field. And an example might be, if you have an image file that can be uploaded and you have a constraint, you tried uploading a 3 MB picture which is too big, and a file with nothing in it which is too small, or you can find a comfortable size image file of 50 KB and try uploading all three and see how your production code works. And the other principle that can be used on positioning of your data is the beginning, middle, and the end principle. So if you try, you can try applying it to an item selected from a list, where you are inserting an item into the list, into the beginning, try inserting at the end, and try inserting in the middle. So this will reveal or explore your production code even more. And the next principle is the count 0, 1, many principle, which says for every example, you can create invoices with the 0 line items, 1 line item, and many line items. This reveals how the software works for multiple cases. Many systems have small typographical error related to plurals. That is, they report one items found instead of reporting it as one item found. So all these will be revealed during exploratory testing. The next principle, which is very, very important in database related software production code is the CRUD principle, the create, read, update and delete principle. So in this principle, you try interacting with the database. Every time you interact with the database, you try to create a field, read that field, update that field and delete field. So every field in the database, you try to do all these 4 operations at least once, so that you check on how your production code behaves every time you do any of these 4 operations for every field. Now try this CRUD while it is violating some constraints such as permissions. So you have some user permissions which are set not to read any of these contents. So you check on some of these constraints and see if your production code is allowing or is it throwing an exception, etc. The next principle of heuristics in exploratory testing is the command injection. Whenever your software supports text coming in from external sources such as web interfaces or UI, ensure it doesn't ever interpret incoming text commands. So your software might internally have some SQL or JavaScript commands or some shell command line arguments. Make sure your external source or the data that comes from the external source does not interrupt or interpret the incoming text command. Now, these are some of the tools that we can use in exploratory testing. Now, when we talk about exploratory testing, these are some of the important points we need to remember, or you can have them as your takeaway message from the session. The first thing is exploratory testing is a style of testing in which you learn about the software while simultaneously designing and executing tests, using feedback from the previous test to inform and guide you to the next. Rather than designing a huge suite of tests upfront, you design a single test in your head, execute it against the software and see what happens with the result of your test. The result of each of these tests lead you to design the next, allowing you to pursue directions that you wouldn't have anticipated if you had attempted to design all that tests upfront. And there are 4 major exploratory testing tools. The first one is charters, the second one is observation, the third one is note taking, and the fourth one is heuristics. Under heuristics, we have seen different principles that help us or guide us in the heuristics. The first one being none, some, all. The second one is Goldilocks, too big, too small, just right. And the third one is precision, beginning, middle and end. And the fourth one is the count 0, 1, many principle. And the fifth one is associated with the database, which is the CRUD principle, which allows you to create, read, update and delete data entities. And the last one and the sixth one is the command injection principles. Thank you for listening. See you in the next session. Thank you. This is Dr. Diana signing off.